In the previous video, we generated a Koch Snowflake using a recursive function. This program here uses the recursive function f to generate the snowflake design, and a for loop here to generate all 6 sides of the snowflake. Watch the previous video to get an idea of what this code is doing. This code is a bit hard to understand what it's actually doing because of the recursion. This function f is calling the function f multiple times. So in itself, a single call is actually multiple calls to the function f. It's confusing to look at. Recursion can be avoided altogether by typing all of the turtle commands individually. Here I have a program that doesn't use any loops or recursion, just explicit moves to the turtle. I'll run it now so you can see that it produces the exact same image. This program here, though, in order to generate the same image, is over 5,000 lines of code long. It's very long. The recursive version, which we wrote last video, is much shorter, but much more difficult to read. We're not sure right off the bat how to unpack all these layers of recursive functions. But on the other hand, it's only 20 lines of code long. And here, when I run it, you'll see it produces basically the same image. Not basically the same image, the exact same image. And that's why computers are good. They're very good at doing very similar things over and over and over again. So recursion and loops are one way to utilize this to save you a lot of time in writing a program. Sometimes it takes more time to figure out the logic of how to actually implement recursion and loops. But in the end, it usually saves you a lot of time in writing your program. Instead of writing 5,000 lines of code, all you have to do is write 20 lines of code.